Hi, this is Usman, and today we are starting this CCNA and CCNP classes for switchings. So there is very important topic of spanning tree protocol. Actually, spanning tree protocols come into the picture when we want to implement a redundancy in our switches. So in redundancy, there is a loop will come. Suppose these switch are connected with each other, so it has updated his MAC address inside that one. They are getting this switch A is getting the information from the switch B on both port 1 and 2 port. So it will send the traffic on both sides. So this will cause a loop method. Same in switch B, it will be forward the traffic as per their table. They have one port and two port, so it will forward the traffic in both ports. So this will create a loop. So in order to prevent, by default in Cisco switches, this spanning tree is enabled. So this is actually 802.1d is the standard for this one. So what actually this spanning tree performs? Spanning tree performs a root bridge elections. So actually, the in root bridge elections, what we will do, there is a this there is a BBDUs has been sent between the switches every 2 seconds. So BBDUs has been forward. So BBDUs are bridge protocol datagram unit. So what it will do, it will add the bridge priority and MAC ID. So it will combine that one, and if a switch getting low value, so it will be selected as a root bridge. Like if you say this is the A is the MAC address of this switch and 3268, so lower one is A. So actually he will got this one as a root bridge, and this one not a root bridge. So what is actually BBDUs is containing? So BBDUs actually contains there is a 35 bits BBDUs, and it contains priority. It has MAC address of the port where the port is connected. So it has sender bridge ID, MAC address, and this one plus A. This is MAC address. So actually, if this one, and there is a root pathcast. So I will explain that root pathcast, and there is sender port ID. So they have this one information in that one. So they are sending these BBDUs with each other, and they will select it as a one as a root bridge and other is a normal. So if a switch is selected as a root bridge, so their both ports are DP, and the other ports is one is root port and one will be blocking state. So we will describe this one, what how the root port election and something like that. So first we need to understand that this BBDUs has priority, MAC address of the port, sender port ID, root path cost, and sender port ID. Center port ID is actually hexadecimal, so it always shows 128.1. If port number is 1, so it will add this one. So here also we have root path cost and this one. So when these switches are combined together, so they are exchanging the BBTs like this. They have this priorities by default. So MAC address is a tie. So if a switch has a lower MAC address, so it will be elected as a root bridge, and he also has root path cost. Root path cost is like there is a speed, and according to that there is a cost. So if suppose we have 100 Mbps link, so we have 19 path cost for that one. So this is also information in that one, and that is a sender port ID information in that one. So this is switch A, and they have this information BBDUs. He is exchanging it with this one, and this is our switch B information. Sorry, there is a B there. So this is not a non-root bridge, and there is a root podcast and sender port ID. So in if a switch is selected as a root bridge, so their both ports are DP, designated ports, and it will be in forwarding state. So in non-root bridge, one port will be root and other will be blocking port. So how this root port election is done, that we will describe. So first we will understand how this uh, election is working. So this is our diagram. So first of all, we will understand this is our root bridge. So both ports are DP. These are root port, and one will be blocking, and this will be DP port. Sorry, this will be DP port, and there is root port, and there is root port. So like this, there is an election is going on, designated port and root port election. So designated port is always there is one switch which has a root bridge. Is both port are DP, and one more switch where the port second port is blocking. This will be a designated port. So there is also root port election there. So we need to know how this root port election is selected. So for this one, for root port election, we have path cost. Okay, path cost. So what is the path cost? I will explain this one. This is a path cost. This is again the bandwidth. If 4 Mbps link, we have 250 cost, and if 10 Mbps, we have 100 Mbps card. 16 MB, we have 62. 100 Mbps 90. 1 GB 4, and 2 GB 3. 10 GB 2. So this actually this is regarding the root port election. So designated port is always, you remember, this designated port is only the root bridge one always has that designated port. So other will be root port. So we now understand what is the root port, how it is elected. So path is like that. If suppose we are using 100 Mbps link, so what is the scenario here? So see this one, we have designated port, and the path going to the root bridge will be the root port. So for the root port election, we need first is the cost. Suppose this all links are 100 Mbps, so 90 is the cost. If you see this one, this DP selected, and the alternative port of this one is the root port, and this is also a root port. So this will be root port, and this will be root port, and same like this one. So here we will need to know how the port is elected. So suppose this is switch A, switch B, switch C, switch D, and so I will put that name. That's the better. So this is switch A, switch B, C, D, and like that. So what happened? If we go to this root pathcast, we need to from this side it will be 90 and 90. So there will be 38. 38 will be pathcast. So if we go from there 90, 90, 38, and this one is 90. So 38. 38 plus 90, so it will be almost if 8 9 plus, we will get we will use the calculator. 57. So 57 will be cost, and if it search from the 90 90 90 4 times, it will be 19 multiplied by 4. So it will be 76. So from here to here is a 76. So When this path cost is see, the lower path cost will be root port. Suppose from here to go there is 38, so this will be root port. This 19 is 90, 38, so it will be this will be root port, and the other one which have more cost will be in the blocking state. So you understand that if we want to go this root bridge, so we need to calculate the cost. So 19, 90, 38. So this will be root port. It will be not blocking state. So if going from here to there, it is 90, 90, 90, 76. So it will be there will be more cost from going from here to there. So if the cost is more, that will be selected as a route that is selected as a block port. Suppose if our root cost path is tie, like in this scenario, we have this DP port. This is our root bridge, and this is a root port, and this is also root port. But about this one election, from C to B, what is the root port cost? This is 90 and 90, 38. And even from here to here is 90, 90, 38. So there is path, this cost is tie. You understand that this 90 and this 90 will be 38. So from C to B is 38. And from D to A is 38. So our pass cost is tie now. So what is the second option we have? We have sender bridge ID. So sender bridge ID is this one. So this will become a root port because we see the receiving end. So this will become a root port, and so we will use the sender ID as a root port in that one. So C will be designated port and D will be blocking port. So if we go in another scenario where both this cost and bridge ID, sender bridge ID is tie. So in that one, what we need to do? So we will go for the third option, which is sender port ID. So in sender port ID, if you see that one in this scenario, we have two switches combined and we connected these switches with one another. So what happened? If you see this will be DP, this will be DP. So one port will be root port and one will be blocking. So how this root port is selected? So DP, DP, this one. So if we go for cost is 90, cost is 90. So this cost is cost from A to B is equal to 90 is equal to the cost B to A is equal to the, so both are 90 cost. So our cost is 90, and sender bridge ID. Sender bridge ID is always this one. This is a receiving end. So sender bridge ID will be 37628 plus A. So this will be both sides will be same. So sender bridge ID also tie. So then we will go for port ID. So port ID will be, this port is 1 and this is 3. So sender, and we will check there which is the port ID. So 128 plus 1, this is a port ID we are getting in this port, and this is a port ID we are getting in their port. So which one is lower? This one is lower. So this will be root port and this will be blocking port. So you hope you understand. I will revise this one, that there is a root port election. Root port election have a pass cost, and if it is tie, we will go for sender bridge ID, and if sender bridge ID tie, we will go for sender port ID. So this first scenario, we will see that this is a normal our root bridge elections. So we will understand where is the root port and something like that. So designate port election, and if the root port path cost ties, like 90 from here and 90 from here, C to B is 38, D to A 38. So in that case we will use sender bridge ID. So which one has a lower sender bridge ID will be selected as a root port. So always we do not need to see there, we need to see the connected interface. So this will be root port, this is already root port, and this will be root port. So from C to D it will be blocking, because C has high sender ID. So this D port will be in blocking state. Okay. So when both are tie, like sender bridge ID and our cost is tie, so then we have a root port, because if you see there, this cost is 90, this cost is 90, so this is tie, and sender bridge ID is 32768 plus A from both ends, because we always see the receiving end, this one. So 32768, so these both are same, so it will be tie. So sender bridge ID also tie, but when we see the sender point ID is 128, so this is 128B. So this one lower, so this port is elected as a root port, port 3, and port 4 will be in block state. So hope you understand this one root bridge elections. Thank you for your time. Bye.